Hello, everyone. We are back with our last lecture talking about asynchronous networking in JavaScript. Today, we'll be covering the newest kid on the block, which is, where is my laser pointer? Async await. This is interesting stuff. So our roadmap, we started off talking about the client-server model in Ajax. Then we moved on to concurrency with JavaScript. Then we looked at XML HTTP requests. And last time we looked at promises. But now, finally, we're going to be looking at async and await with fetch. So we build up this nice abstraction, right? Promises. But we had a similar problem with promises that we did with this XML HTTP request, which is that we're writing functions that, and we're programming in a way that's just different from the way that we're used to. That's where async and await come in. So if you look at this, finally, we have this like nice function. We just do stuff in a function scope, right? With these nifty new keywords. So these two blocks of code do the same thing. Personally, I think the async await version looks much better, but let's talk a little bit about it. So in ES 2017, async and await was standardized. And now in the year, well, now they are supported by virtually all browsers. And what I've linked here is the support map. If you scroll down, the bottom of the web page will be the browser support map, which is all green except for like Internet Explorer 11, which I think Microsoft has deprecated now anyway. So it doesn't really matter. But if we look at these different ways of writing code now, we can see that for await to happen, we kind of have to stop at the fetch, right? Because fetch is actually doing something in the real world. It's going to take time as it's downloading from the internet. So we actually have to pause here before we can move on. And this is what's this like pausable and resumable functions, as it's called. These are known as coroutines, if you want the technical jargon. But that aside, it's just essentially resumable functions. That's what we want. And the reason why people generally talk about this after promises is because async and await are built on top of promises. So, oops, one thing. Are built on top of promises. So you kind of have to have background knowledge of how promises work before you can fully understand how async and await work. Trusted, you don't have to understand all of the nitty gritty, little bitty details, but it's generally good to know what you're doing. Specifically, async functions will always return a promise. Even if you return a number out of get movies, it will be a promise of whatever that number is. And these await expressions, so this await whatever, will always unwrap a resolved promise. And if the promise that, say, this fetch URL returns isn't fulfilled and is rejected, that will be thrown as an exception. So what that means is that we can finally do things in the synchronous and intuitive way that we're used to, like probably when we started programming, right? So there we go. Let's talk a little bit more about how this works, the details of how this works. Now, the goal of this is to try to get an intuitive understanding rather than knowing the exact specification and standard of how a browser does it, right? So let's say we have this piece of code here. This async function foo, it takes in a v, doesn't really matter what the v is. Then we have this const w, and what we are doing is we're awaiting this v, and then we are returning whatever this returns, whatever this await expression returns, right? So the reason why I say v isn't important what it is because we can even await things that aren't promises. Because what happens is that we actually create an implicit promise in our mind. This doesn't actually happen. This isn't real code. But let's say v isn't a promise. It might be a venable. Maybe it's a number or something. Then it will still be wrapped into a promise. It's just that this promise will have already resolved. So it kind of creates a promise that is that value or resolves to that value. To this promise, we then add the code that resumes this function through specifically at line, well, it would be after line 2 technically, kind of like in this assignment, because we have to do this and then we can do the assignment. But to this implicit promise that we create, we are attaching to that all the code, all of the state, all the stuff necessary for the JavaScript runtime to resume the function at that point. And if this doesn't, what am I looking for? Yeah. So remember, .then takes in the function for when it passes, when the promise fulfills, and then it takes in an explicit error handler. Here, if the expression rejects, then we'll throw an error. And so this implicit promise will also reject. Yeah. And then basically, after the code has been injected, then we suspend this function at this point, and we wait for the asynchronous operation to complete and either fulfill or reject. And then if it fulfills, then we'll take the result and stick it inside a W when W is resumed. And then if it rejects, then we'll throw in, then this expression will throw an exception and we'll have to catch it somehow. Otherwise, we just keep going and we return W. Things to note, important things to note is that the promise that foo returns will resolve once we reach the ending brace or the return or a return statement. So when the foo function falls off the end of its execution, that's when the promise that's returned by foo is resolved. And if an exception is thrown or there's an unhandled rejection for any of the await expressions, then that will count as foo being rejected as well. It kind of makes sense, right? If you're awaiting something that rejects and you don't deal with it, then you also reject because you're depending on something which doesn't happen. Yes, that's basically everything that I've talked about. Again, this isn't super important. It's just you kind of want to get a feel for what's happening here. Why is it that async functions return promises? Why is it that, or how is it that we can await things that themselves are not promises? You can do await 5 in JavaScript, and that will actually do a thing. It's just that 5 gets wrapped into a promise that will immediately resolve. But that's essentially how it's working. And like I said, because we are now able to write this code, this await expression inside of a regular function, we can use regular function stuff. Like we can use try catch blocks again, because if this rejects, like I said, this will just throw an exception. But we stop at this point. So when we resume, we're again inside of the function state, because the JS runtime will capture all of the state and store it for us. So that way, when we resume, everything that we were looking at still exists, right? Which is awesome. So let's say we have, this is the way this would work in the promise version, right? We're fetching this non-existent URL. We'd have to attach this catch error handler to the fetch, because if you remember from last time, we can't wrap this operation into a try catch because it happens in a completely different scope. Here, it's different. So this line will still create a promise, right? But when we await the promise, we stop there and wait for it to happen. And that's why we can use the try catch, right? Because when we resume, we're in the same scope. Now, the next thing is that promises are still promises. You know what I mean? What I'm trying to say is that when we just call fetch like this, Baz will contain a promise that is in the pending state. It hasn't happened yet. So you have to make sure that if you do use a try catch, that you make sure you use the await keyword. If you just say try Baz and you leave off await, then nothing will happen. And we'll be back in this land where we fall off the end of the function capital F foo, and then if this rejects, it will reject in its own scope away from this try catch. So the main takeaway is that you have to be sure that you are using the await keyword. You have to use the await keyword. Cool. So that has been an intro to async await. It's not too big of a conceptual difference from promises, but let's look at an example. So again, we have our Chuck Norris meme generator, which I think this will do nothing still, because there was a network error. Am I still being throttled? Oh. We'll come up, and we have our stuff, which is good. What we're going to do is we're going to convert this previous, there we go, always forget the blob. We're going to convert this previous fetch example from the previous lecture, and we're going to convert it to using async and await. Okay. The first thing that we need to do is that we need to add the async key, function keyword, which is already there. Awesome. And then the next thing that we need to do is we need to grab these code blocks that are inside of these .thens, and we're going to move them into get filed scope. I should call this get meme, shouldn't I? But oh well. Actually, I can do that right now. There we go. Yeah, just that. Okay. So let's go ahead and move this code. We'll just cut it, stick it there, and then we'll grab this, and we'll just stick it under it for now. And we'll also grab this code, and we'll just stick it below as well. And then we can just remove this. So we're going to be doing all that async await stuff inside of this try catch block. And because this is our error condition, we're just going to stick it up inside of here. And then we'll move all of this non-error stuff inside of the try. Cool. Okay, so we are missing this res variable, so we need to go and create it. Remember, fetch returns a promise that will eventually resolve to the response from the server that we're fetching from. If I just leave this code as it is, res will be that promise, right? So what we need to do is we need to await this. And this will now unwrap that promise for us once it resolves. All of this should be fine still if the result was okay. So if we didn't get an HTTP error, then actually we do need to change this. We'll go into here. We don't need to return res.json anymore, right? Because we're working in the same function scope that we would normally, right? We can go back to being in our mind synchronous, or at least write it like it's synchronous. So what we need to do is put that inside of there. And actually, you know what I might do? I might just flip the error conditions. That way we're back. So I can get rid of the else block and move this below. Cool. So now if the result is not okay, we'll just throw a new error and we'll go inside of our catch block, same as before. But now we are one less level of indent, which is good to see. But we are missing our data variable before, which held the JSON. And if you guys remember that when you're dealing with fetch, you have to grab the result by chaining with the .then, but you will then also have to get the JSON by chaining with the .then. So that means that if we want to get to the data, consts, we can't just say res.json, because that would just return the promise, right? Again, we need to use await so that we unwrap the promise like this. And now data will stop at this point and grab the JSON. And then when we pick back up, we'll be outside, we'll be back inside of this function, and we can just continue normally. And that should be the main transformation. So if we go and look at the web page again and we do a reload, it should work. And it does. In fact, it's somewhat faster, I think, than using the promise one, but I'd have to benchmark. The easiest way for chuck notes or chuck women is to turn up. Terrible. What's another one? All science students stuff. I don't really care. But that's how that works. And you can see, right? We're inside of this try catch block. So let's go ahead and create some errors. So let's go and throttle ourselves. If we do that and we try to go, you can see that we're inside of the try catch block and we went inside of the catch clause, even though all this stuff is happening asynchronously, right? Let's unthrottle ourselves. And what we'll do is we will access our 404 blob. And now if we go again, you can see we got a 404, right? That's an HTTP error. It wasn't a rejection caused by a network error. It was just an HTTP problem. And then we go into this if block and we throw the new error and we come back out inside of this catch. So like immediately we can see the benefit of this, right? All this is happening inside of this function scope. It's as if that this is all happening without us stopping and starting, right? Truly useful in my opinion. There is one thing that we have to remember, which is that we don't have the ability to await at global scope. We can't do this. Get mean. We can't do this. We always have to, at the very top global scope, we have to use a promise. I believe that there were proposals for JavaScript to allow this and create like an implicit promise handler. I don't think that has happened yet, or it might have. I'm not too sure, but it's still just a good idea to remember that because getMean still implicitly returns a promise, that you deal with it at the top level as a promise. So you add the dot thens and the catches and all of that. This isn't giving me an error, so it leads me to believe that probably the latest version of JavaScript will in fact let you do this. So let's try this out, shall we? Oh no, there we go. Uncaught syntax error. Await is only valid in async functions and the top level bodies of modules, which isn't this. This is not the top level body of a module, so we can't do that. So it still isn't standard JavaScript to be able to do that. That is that. Let's go back to the presentation. Put me back up here. Yes. So we know that XML HTTP error is fairly legacy, right? And that it's not used very much. That's why we introduced promises. But now we have promises and we have async and await. So which should we use? What are their trade-offs? What are the pros and cons? Well, I mean, it's not always so clear cut. With a promise, right? Promises are good. We can pass them around to different functions because of like an object, right? And you can attach different handlers and make up this really complex control flow. I mean, you do pay for it though, because when a promise rejects, you have to keep a stack trace so that way you can give an informative error of what happens, which means that promises generally are more memory intensive than async and await. And I mean, just based on the time, promises introduced ES 2015, async and await introduced into ES 2017. I mean, that's 2 years difference, which doesn't sound like very much, right? But in the world of technology, 2 years is quite a long time. So promises supported on more older browsers, async and await. I mean, virtually all modern browsers support both. So it's not that big of a consideration, but if you're going like way, way back and still dealing, like there are still systems that use Windows XP, right? Even though Windows XP's end of life was like 10 years ago or something. So, I mean, legacy code is always a problem, right? With async and await, it's easier to read. At least I think it's easier to read. Like if we just look at it, personally, I am much more of the functional way where we have an async function and await, but perhaps you disagree and you think that adding handlers like this is easier to read. It's a debatable point, but I believe that async and await is easier to read. And probably a lot of people do as well, which is why it was introduced, right? Async in a way might be harder to debug. If you've ever tried to write a large application using async and await, you'll notice that you can't just step in your debugger because things aren't happening synchronously. Async and await gives us the impression like it's still happening synchronously, but it's not. It's happening asynchronously. So debuggers will jump around and it's very difficult sometimes to see what's happening. But with promises, again, everything that happens inside of this code block is synchronous. So you can just step through that really, really easily. And every code that you pass on to a .then is easier to debug because you can just step through it line by line. Whereas with async and await, you'll have to be tricky, or you have to be like sneaky and like put breakpoints on the next line instead of stepping. It's a acquired skill for sure. Now, again, because promises take up more memory, they can be more memory intensive, but async and await, the whole mechanism that does the resuming and suspending is generally done with native code, like whatever your JavaScript engine is written in. So like it's generally heavily optimized, right? Which means that in some cases it can be more performant if that's important to you. And again, because async and await allow us to write code in the synchronous sense, it's more familiar, right? So that might be a consideration for like developer resources. So like ultimately it comes down to what are your specific needs? What problems do you have? You know, maybe you don't have full control over your environment, right? Maybe you're in a work environment and you just have to do it this way. Maybe you are targeting very, very old browsers to maximize your audience, potentially. Maybe you need high performance. Maybe you're like 3JS and you're writing like a game engine or like a linear algebra math library in the browser, which I mean, I don't know why you would, but you could, right? And you need that performance. You can't be super memory intensive. You don't want to take up a gigabyte per tab. So trade-offs, benefits, it's our job as engineers to weigh up all these different things and make an informed decision, right? So finally, right, we've gone through this journey. We've built up enough understanding to make an educated decision about how to make an Ajax web app in JavaScript, right? We know about the event loop. We know about legacy options. We know about promises. Now we know about async and await. We can make all of this stuff happen as a reality rather than as a dream. So to wrap up, today we did async and await, and we did our example with fetch, right? We know that we can accomplish our Ajax dreams by XML HTTP request and promises and fetch and async and await. You know, there's probably going to be more technologies in the future. I don't doubt that at all. In fact, the functional programming paradigm is gaining very much a lot of traction. So perhaps we'll see more things that they use. I really don't know. So you know, even though the technologies continue to evolve, the fundamentals will probably not change. So everything that we've talked about over the last few lectures will be relevant for now and probably well into the future. So that is the end of everything. Thank you all for watching, and I wish you luck in creating Ajax web apps. So see you later.